Alright, write these expression as a sum and or difference of logarithm, express powers as factors. So this is going to fall in that that middle row of properties. So if I look back at those properties, it's ways to rewrite, to expand it out. So we're going to be going from the top to the bottom, or this one to that one, or that one to that one. So if we look at these problems, we have log base 5 of 25 times x. So we're going to write log 5 2 times because there's 2 things inside there. Your first thing is 25. Your second number is x. Since they're being multiplied, you put plus sign, and you're done. So what you're doing is splitting it apart. So see if you can do this one on your own. So we have log base 3. We have x and we have 9, so I'm going to rewrite it twice. So I have x and I have 9. Since it's division, you're going to subtract. So see if you can do this one on your own. ln is natural log. It works the same way as log. So we're going to write it as ln of x squared plus ln of the square root of 1 minus x. So that is splitting it apart as a sum or a difference. However, it says express powers as factors. So here's the power. The very bottom property in that column says you can move the power out in front. So we're going to have 2 ln of x plus, what's our power when we're taking the square root of something? You should say a half, so you get ln of 1 minus x. So see if you can do this one on your own. We got log 5. We have the cube root of x squared plus 1 minus log 5 of x squared minus 1. And some of you are like, well, why is it minus? Well, because it's division here. So this is the cube root, so that's the 1/3 log 5 of x squared plus 1. The squared cannot move out in front because it's only on the x, it's not on this whole quantity there. Minus, here we have x squared minus 1. That squared cannot move out in front because it's not on the 1, it's not on the whole quantity. So you still get log 5 of x squared minus 1. For those of you that like to go for extra credit, this back part, x squared minus 1, can be factored. So you could put x plus 1 and then write another log and put x plus minus 1 on that one. So try this big kahuna one on your own. Alright, you should get a third ln of x squared minus x minus 2 minus a third ln of x plus 4 quantity squared. Well, the squared can move in front, so you get negative 2/3 when you multiply, and then x plus 4. For those of you that want extra credit, this can factor, so you get a third ln x minus 2 plus a third ln x plus 1. And that could be your final answer. So now we're going to rewrite it as a single logarithm. So we're going to put it back together. So we're only going to write log, looks like our base is 3, one time. So we have to determine what the 2 does. If the 2 is in front, that means it's an exponent for u. So we have u squared. If there's a subtraction sign, that means we have a division. And v. V does not have an exponent because there was no coefficient out front. So see if you can do this one on your own. You should get that you write log 4 once, that your top has x squared minus 1, no exponent, over your bottom would have x plus 1 to the 5th. The reason it's on the bottom in its division is because there's a subtraction sign there. For those of you that want extra credit, you could factor the top to x plus 1, x minus 1. Your bottom stays x plus 1 to the 5th. Notice you have an x plus 1, so those could cancel out, and that would become to the 4th power. So try these two on your own. So pause the video, then unpause. Alright, so we get log of x squared plus 2x minus 3 over x squared minus 4, all divided by, this is all under the log, of x squared plus 7x plus 6 divided by x plus 2. Yowzers! In the review chapter, you learned how to simplify this. So, you learned that you could factor the top to x plus 3 and x minus 1. That your bottom is x plus 2 and x minus 2. And then this part, you flip the fraction and multiply. So x plus 2. This part factors to x plus 6 and x plus 1. So you can cross out those. Now this would be for extra credit. So you get log of x plus 3 and x minus 1 on top over x minus 2 and x plus 6 and x plus 1. Notice this didn't have a base on the log. That means your base is 10. If it does not have a base on your log written there, it is assumed that it is 10. So for this one, you're going to get log base A of 5x cubed squared divided by 2x plus 3 to the half. And there's your answer for that one. So the change of base formula is the last thing that was on that first slide. What the change of base says is I can type in my calculator log 21, and if I don't put a base there, we're going to assume that it's 10, over log 3. My thing is 10 here as well. So if your thing is 10, you can type them in your calculator, because that's how your calculator is programmed. If it's not a base of 10, then you can't. So that's where the change of base formula comes into play. So if we type in log 21, make sure you close your parentheses if you're using a scientific calculator or a graphing calculator. So we got log 21 divided by log 3 equals 2.77, we're going to go 3 places, 1. So see if you can do the bottom one on your own. You would do log of 8 divided by log of the square root of 5. So type that in. And you get 2.584. You're done. Now, it's not always the smaller numerical value that goes on bottom. It's whatever your subscript is on the bottom. So watch that. And that is it for notes for next time. Please come with questions for your quiz prior to quiz day. Do not come to me at 7:30 on quiz day asking questions. I probably won't help you.